Okay, so we did Unit 1, which is the basic math and arithmetic. Unit 2 is about algebra and measurement. So we're going to start out today dealing with a little bit of basic algebra. Just a little review. We looked on the first day, we looked at algebraic numbers and how those work. And we talked about 4x and what it means a little bit. It's just like having 4 inches or 4 sevenths or 4 cows. There are two parts to it. There's a count that tells us how many. We have 4 of something. And then there's a name that tells us of what. Just like having inches or sevenths or cows, here we have x's. Now, the difference is, oops. So again, just like inches or sevenths or cows, that x is telling us the name. The difference is we don't necessarily know what an x is, but we do know what inches and sevenths and cows are. But it's going to behave exactly the same. So if we have 4x and we want to add 9x to it, just like if we had 4 inches plus 9 inches, we combine the counts. 4 plus 9 is 13, and we keep that same name of x. Or if we had things that were different names like 5x plus 7y, we cannot add those. We can't combine those with addition or subtraction because they have different names. Now we should look at dealing with multiple statements like 5x plus 7 minus 2x plus 9. If we have something like that, we see that there are different names. This has a name of x, and this, when there isn't a name next to a number, that's just its place value, or ones in this case. We can't combine those two with addition because those are different names, but we can combine some of the pieces. We have 5x. Now this one isn't 2x, it is actually a negative 2x. So 5x and negative 2x make 3x. 7 and 9 make 16. And now since we have to have something to link them together, since that's a positive 16, we put plus in there, plus 16. If we were multiplying, 5x times 3x, we would combine the counts. 5 times 3, we're multiplying this time, so we combine it with multiplication. So 5 times 3 is 15. But when we multiply or divide, we also combine the names. So x times x is x squared. Also, when we multiply, we don't need to have the same name. We could have 6 times 4x. And even though those have different names, we can still combine them. Combine the counts. 6 times 4 is 24. Now, a lot of times we'll say nothing times x is x. But this is, remember, this is really the place value here of 1s times x is just x. So 24x. I'm not going to waste a lot of time with simple multiplication, but I'm going to jump up to something a little more complex like this. 8x plus 5 times 3. Now, most of you, when you went through your basic algebra course, learned something called distributing, and we'll come back to that. But technically, the way the long way to multiply this is the same way you would multiply 32 times 3. You would do 3 times 2 is 6, 3 times 3 is 9. Well, the same thing is going to happen here. You have 8x plus 5 times 3. 3 times 5 is a positive 15, so we put the plus in front of it. 3 times 8x is 24x. And you get the result. Now, we don't like to have to write it out this way to multiply it out, so they came up with a shortcut that most of you learned as distributing. Looks like this. Distribute the 3 through the parentheses because it's multiplying the parentheses. 3 times 8x is 24x. And then 3 times 5 is 15. It's a positive 15, so plus 15. Gives us the same result. We have to be careful. We can run into something like this. So negative 7 times 2x minus 5. we're going to go ahead and distribute since I'm sure most of you have seen that. So it's a negative 7 that we're multiplying by. We have negative 7 times 2x. Negative 7 times 2 is negative 14. And then, of course, just the x. And then we have to be careful here. This is not a 5. It is a negative 5. So negative 7 times negative 5 is a positive 35. So just a little bit on combining our algebraic terms that we're going to need to be able to deal with later. The main point of today is to deal with things that look like this. X equals a number, or a variable equals a number. This, of course, is an equation, and the key to it is to understand that symbol right there, which is the equal sign. Can anybody tell me what it means? Kind of hard to define it without using the word equals, isn't it? Everybody says, well, it means equal. Well, it does mean equal. But more importantly, more technically, what it means is whatever is on one side has exactly the same value as what's on the other side of that symbol. In fact, you could think of it as being a balanced scale, where everything perfectly balances around that equal sign. Now, all of our equations start out just like that, as a variable equals a number, or a number equals a variable. And they are built up from there. For example, one thing we could do to build onto this equation, I might add 7 to it. So x plus 7 is now x plus 7. But because it's a balanced scale, if I add 7 to one side, that scale is going to tip unless I do exactly the same thing to the other side to keep that scale balanced. So 4 plus 7 is 11. So it's now 11 on the right side of the equation. So we just built a slightly more complex equation. Now, when we are asked to solve an equation, what it is asking us to do is take the equation apart and get it back to this original form here that it started at, as a variable equals a number. So looking at this equation, it was built by adding 7. So to take it apart, we're going to subtract 7. Subtracting 7 removes that piece, leaving us with just an x. Now, just like up here, if we do something to one side, that scale is going to tilt on us if we don't do the exact same thing to the other side. So we're going to subtract 7 from the other side. 11 minus 7 is 4. So we just solved that equation. We just took it back apart and got it to its original form, as x equals 4. Now that one was pretty simple because we built it, so we knew how it was built. The tricky part is to look at an equation and figure out how it was built. So to do that, to look at, and I know these are pretty simple. Most of you can look at that one and have the answer almost before I'm done writing it. But to figure out how an equation was built, what we need to do is we find the equal sign right there. Then we identify which side of the equation has the variable, which is over there. And then we have to ask, what is keeping the variable from being alone on that side of the equation? In this case, it's the 3. The second question then is, what operation is attaching it? What operation was used to build that 3 onto the equation? Well, the 3 was subtracted. So to take it apart, we're going to do the opposite, which would be adding 3. So the subtracting 3 is now gone. We've removed that piece, leaving us with just the y. Now, just like over here, if we do something to one side of the equation, we have to do the exact same thing to the other side. We added 3 over here, we're going to add 3 here. So 9 plus 3 is 12. So y equals 12. If we're unsure of ourselves, we can always double check by going up to this original equation and replacing the y with 12. And seeing if we get the same value on each side. So replace the y with 12. 12 minus 3 equals 9. So we do have the same value on each side of the equation. We might have 5z equals 45. Now again, I'm going to go through the steps, even though I know most of you have this solved already. Here's the equal sign. Here's the side with the variable on it. The 5 has been built on, and it's been built on by multiplication. So to remove it, we are going to divide. Dividing by 5 removes the 5, leaving us with just z. Making sure we do the exact same thing to the other side. 45 divided by 5 is 9. Well, those are pretty simple. Let's step up to something a little more difficult. Let's look at this one. Now we find the equal sign right here. We identify where the variable is on the left side here. Now we have to ask what's been done to build this. What has been done to the variable? In this case, what's been done to x to build this? Well, we have the 7 and the 3. The 7 was subtracted, the 3 was multiplied. Order of operations tells us that we multiply before we subtract. So when this equation was built, x was multiplied by 3. Then the 7 was subtracted from it. So now when you go to take something apart, well, let's say you put something together. You get a shelf or a kit or a model or anything. You put it together and you've just put that last piece on. You just finished putting it together. And you go to take it apart. The first piece you take off will be the last piece you put on. So the first piece we're going to remove is that subtracting 7. You may have heard some of your algebra teachers refer to this as reverse order of operations when you're solving equations. And that's why you're taking the equation back apart. When they put the equation together, they had to follow the order of operations. When we take it apart, we have to go backwards. So subtracting 7 was the last piece put on, so we're going to add 7 to take that piece off. So that's gone, leaving us with 3x. Adding 7 to the other side gives us 21. Now we can remove the 3 by dividing by 3 to get x. Dividing by 3 equals 7. Let's do another one of those. So looking at this one, again, what's been done? The z has been multiplied by 5, and then 2 is added to it. So to take it apart, we'll subtract 2. Leaves us with 5z. Subtracting 2 from the other side to keep it balanced is 30. And we divide by 5. 6 equals z. As always, we can double check. Let's replace the z with 6 and make sure it works. So instead of 5 times z, it'll be 5 times 6. So this side's just 32, nothing to do there. Applying our order of operations over here, 5 times 6 is 30, plus 2 is 32. We have the same value on both sides. We can get a little bit more complex than that. We can run into something like this. Now, as always, we find our equal sign and we identify which side has the variable. Over here, the x is on the left side, and in fact, it appears twice on the left side. Now, if we think of this example of a balanced scale again, having 3x and 2x on the same side of the scale means we can just take them and push them together to make one big pile. And it won't affect how this balances. So 3x and 2x make 5x. We still have the positive 4 or the plus 4. And then equals 59. Now we can go ahead and solve this. 5x plus 4, the first thing we're going to do is subtract 4. 5x equals 55, and we will divide by 5. Leaving us with x equals 11. Once again, if you wanted to, you could come back here and replace x with 11. X appears twice, so make sure you replace both of them. So 3 times 11 is 33. 2 times 11 is 22. 33 plus 34, or 33 plus 4 is 37, plus 22 is 59. So that works out. We might have something like this. This time we find the equal sign. We identify where our variable is, and we see that there's a variable on each side. X appears on each side of the equation this time. But we can't just push them together to make one big pile anymore. We have to get rid of one of them. Normally we get rid of the smaller one, which will be the 2x. Mathematically, how we get rid of it, we're just going to subtract it. It's positive, so we're going to subtract it. It's now gone. All that's left over here is the 36. Positive 36, but I don't need to put the plus in front of it. But whatever I do to one side of this thing, I have to do to the other side to keep it balanced. I took 2x away over here. I have to take 2x away over here. The only thing that has the same name, of course, is the 5x. So 5x minus 2x is 3x. Negative 3. And now I can solve. I'm going to add 3. 3x equals 39. And divide by 3. X equals 13. And again, you can double check. Replacing the x with 13 each time. So this is 5 times 13 is 65. Minus 3 is 62. This is 2 times 13 is 26. Plus 36 is 62. Other types of things we can run into might look like this. Of course, whenever we see parentheses in any math problem, it should draw our attention to that. It should scream at us to do something here first. The first thing we always check for with a parentheses to see if there's anything to do inside the parentheses. In this case, 3x minus 2, there's nothing to do inside the parentheses. Second thing we should check for is to see if there's anything that needs to be done to the parentheses. And in this case, there is. It is 4 times the parentheses, so we have to distribute the 4. 4 times 3x is 12x. And then 4 times negative 2 is a negative 8. And now we can solve. Of course, we're going to add 8. 12x is 48. And we'll divide by 12. X equals 12. Let's do one more like that. Looking at something like this. Now again, we see parentheses, nothing that can be done inside the parentheses. 3x plus 5 cannot be combined. So we're going to distribute the 7. 7 times 3x is 21x. 7 times 5 is 35. And that still equals the 182. So now we will subtract 35. 147 is 21x. And then we will divide by 21. 147 divided by 21 is 7. So 7 equals x, or x equals 7. And of course, as always, you can double check. If I put 7 in here for x, 3 times 7 is 21, plus 5 is 26, times 7 is 182. So we get the same value on both sides. Let's look at something a little more complicated. Let's try this one. Just a little bit more complicated. Took me a second to make sure it worked out even. Now here we see multiple parentheses. So there's two things we can do to break this down. First of all, we find our equal sign. We only have to work on one side of the equal sign at a time. So we're going to start out over here on the left side. And now it's just like our order of operations. There's more than one set of parentheses, so we're going to work left to right. We're going to do this one first, right here. Nothing to do inside the parentheses, so we're going to distribute the 5. 5 times 3x is 15x. 5 times a negative 4 is a negative 20. Next, down to this set of parentheses. I'm looking at that one. There's nothing to do in the parentheses again, so we're going to distribute. But we are not distributing a 2. We have to be careful. That minus there means we're distributing a negative 2. So negative 2 times 7x is a negative 14x. Negative 2 times negative 10 is a positive 20. Now I'm going to combine 15x and negative 14x is 1x, or just x. Negative 20 and positive 20 is 0. So all we have left on that side is x. Over on the right side, we have a parentheses. We're going to start there. Again, there's nothing we can combine inside it. So we're going to distribute. And again, we have a negative 3 to distribute. So if negative 3 times 2x is a negative 6x. Negative 3 times negative 3 is a positive 9. Now we still have the 4x up front and a negative 3 in back. We're going to combine. 4x minus 6x is a negative 2x. 9 minus 3 is 6. It's a positive 6. So we put a plus 6. Now we have a variable on each side, have an x on each side, so we're going to get rid of one. Negative 2 is smaller than positive 1, so I'm going to get rid of it by adding 2x. Even with just a 6 here. X plus 2x is 3x, and we divide by 3. Give us x equals 2. We could plug that back in to verify it if we wanted to, replacing every x with 2. I will leave that up to you to try on your own if you would like to check it. So anyway, now that we have these equations, we need to be able to solve problems with them. And I know some of the types of problems we're going to use at the basic level are pretty contrived and a little artificial, but they're a great way to help us start learning how to write these equations. Now, I realize many of you have done this, so this might be a good review. I found, though, that probably the most difficult task in any sort of math class, even more difficult than subtracting with negatives, is taking a situation and writing the equation for it. So let's go ahead and do a few of those examples. Let's say that Carl and Frank work at a car dealership. And Carl sells 3 times as many cars as Frank. Excuse me. In a week where they sell 36 cars total, how many did each sell? So the key to these is defining our variables. We have Carl and we have Frank. And what we're looking for them is the number of cars sold. Now there's 2 things we're looking for, Carl sales and Frank sales. But we don't want to have 2 variables because we don't know how to deal with 2 variables quite yet. So we need to look and see if there's a relationship that relates one of them to the other. And that's the very first line here. Carl sells 3 times as many as Frank, which means Carl's sales is referenced off of Frank's sales. So we're going to call Frank's sales, number sold, X. Carl, being 3 times as many, would be 3X. And we are given a total of 36 cars. So 3X plus X equals 36. Combining, think of that as a 1X. So 3X plus 1X is 4X. Then we divide by 4. x equals 9. Now we're not done yet. We've solved for x, but we still have to answer the question. The question was, how many did each sell? Well, Frank sold 9 because he was x. Carl is 3 times x, or 3 times 9 is 27 for Carl. Quite a busy week. So let's say that we have shift A produces 4 times as much as shift B. In a week, where shift A produces 240 more products than B. Once again, how many did each produce? So again, we're looking at this time shift A and shift B. And now we're looking at number produced. And we're looking to see if one is referenced from the other. And it is. Shift A produces 4 times as much as shift B. So if we let shift B be x, shift A will be 4x. But the next step is where there's a slight difference. It doesn't say they produced a certain amount total. It says shift A produces 240 more. So there's 2 ways we can look at this. We can say shift B, which is x, plus 240 equals shift A, which is 4x. Or we could have written it as the difference between them. Shift A minus shift B equals 240. Either way would be acceptable. I like the second way because it's a lot easier to solve that way. 4x minus x, if you think of that as 1x, that gives us 3x equals 240. We divide by 3, x equals 80. Now again, we're not done. X equals 80, well, x represented shift B, so shift B produces 80 products. A was 4 times x, so 4 times 80 is 320. So shift A produces 320 products. Well, those are kind of the simple examples. Let's look at something a little more complex. Let's say that we're going to run a stand selling shirts for school with our school logo on it. Let's say we're going to sell t-shirts for $12 each and sweatshirts for $20 each. But if you sell 4 times as many t-shirts as sweatshirts, of course, for a total of, what do I put in here? $3,400. Let's try that. Again, how many of each did you sell? So this ends up being a little more complex. So we got the t-shirts. We got our sweatshirt. We'll start off with number sold again. And again, we can let sweatshirts be X because t-shirts were 4 times as many. So 4X. We sold 4 times as many t-shirts as sweatshirts. But we're not given the total sold, we're given a dollar amount. So we have to find some way to convert these amounts sold into dollars. Well, price of a t-shirt was $12. Price of a sweatshirt is $20. So the dollars collected from each is the price times the number sold. So 12 times 4x would be 48x. For sweatshirts, it's 20 times x, which is just 20x. And now those two numbers, 48x plus 20x, have to add up to $3,400. So if we add that 48 and 20 makes 68x. Solving for x, we're going to divide by 68. X equals 50. Now once again, we're not done. We have to remember what x equals. This is why I always write down what x is before I start the problem so I don't get to the end and forget. X was the number of sweatshirts sold. That's 50 sweatshirts sold. T-shirts were 4 times x, so 4 times 50 is 200. There's 200 t-shirts sold. Now we're going to take a little bit different approach. It's going to be the exact same problem, but we're going to do it a different way. So once again, the t-shirts are $12. The sweatshirts are $20. This time, though, we're going to say we sold a total of 250 shirts for a total of $3,400. And once again, how many of each? Oops. So again, t-shirts, sweatshirts, and we're looking at the number sold to start off with. This is a little trickier. There isn't one referenced off the other this time. We didn't say that one is 3 times the other or 5 times the other or anything like that. What we do have is a total number of items, 250. If I were to tell you that we sold 100 sweatshirts, that means we had to sell 150 t-shirts. We just take 250 minus 150, or 100. Well, we don't know how many t-shirts we sold. So if we call the number of t-shirts sold X, number of sweatshirts would be 250 minus X, minus however many t-shirts we sold. So now the price, of course, is still $12 and $20. So to get the money, t-shirts is going to be 12 times X, or 12X. Sweatshirts will be 20 times a price or number of 250 minus X. Those two amounts now have to add up to the 3,400. So 12X plus 20 times 250 minus X equals 3,400. We see the parentheses, so we start there. 20 times 250 is 5,000. 20 times negative x is a negative 20x. It's a positive 5,000. We still have 2x or 12x up here. Still equals 3,400. We can combine 12x and negative 20 makes a negative 8x. Positive 5,000 equals 3,400. And then, to get x by itself, we're going to subtract 5,000. Negative 8x equals a negative 1,600. And we will divide by negative 8. Negative 1,600 divided by negative 8 is a positive 200. So now we got to go back and figure out what x is. We labeled x as the number of t-shirts So 200 t-shirts. Sweatshirts were 250 minus X, so 250 minus 200 is 50 sweatshirts. So again, it's important to label what your variable is before you start. So once you get that value for X, you know what it means, and you can tell whether that's what you're looking for or if you need to do something more to get your answer. Okay, with that, I think you guys have had enough for today. As I said, I will have your tests graded and back to your facilitators at each location by Wednesday for you. For now, you can do some homework on page 49 through 50, 1 through 43, the odds. With that, we'll see you on Wednesday.